Today we'll discuss about the process of image registration with the help of GIS software, mapping. It is an open source software, free software, which can be downloaded from mapping.org. Now, the basic aim of our image registration is to register an image into the existing coordinate system, which is being used by the GIS software. Now, presently, as you can see in this map window software, this system is using the WGS 84 Northern Hemisphere projection system. WGS 84 3395 EPSG. This type of coordinate system it is being used. This software is used. Now, what we will do is we will try to register an image into this coordinate system. So this is a basic image of the state of Tripura, located in the northeastern part of India, where all the districts are digitized by a polygon shapefile. And if you had watched my previous tutorials, you can understand how I have drawn all this polygon shapefile to represent the average annual rainfall and also the temperature and other pertinent information related to the district. Now, my next aim is to register an image of the state of Tripura into this coordinate system such that I can use that image in the background. And the basic objective of using an image in the background is it helps us to represent the information uh, that is available in the shapefiles on a recognizable geographical feature. Like state of Tripura is recognized, is a well-known feature. So if I use it as a background, then by observing the shapefiles and its location, users can understand that what it uh, about what rainfall or what temperature I am trying to display. That means by what I means the district rainfall of which district I want to display the rainfall or temperature. So in a summary, you can say that to provide a reference image base map to this image, we are using a we are trying to put the real image of state of Tripura into this existing framework. Another advantage of this is that when you calculate the area and length of this district, or if I draw this length, you can see that this is showing 86 meter. But actually, this 86 meter is based on the latitude longitude or the projection system that we are using. But it may or may not be correct. So here what we can do by registering the image in the background, it gives the volumetric ratio between the real image and the shapefile created on that image. So what happens is whatever area it will show, whatever length it shows, we can transform it into its real length by multiplying the scale factor with the length being shown here. Like for example, when an image is used in the background, an image is registered in the background, what happens is you can do like this 86 meter and then check the scale, it is 5000, 1:5000. So multiply 5000 with 86. Whatever amount is coming, that is the exact distance from the central point of this district to the central point of this district of Tripura. So let us see how the image registration works and from where you can find the image registration. So let us begin. So first of all, you must watch my previous tutorial to know how these polygon shape files are drawn upon the district of the different district of the Tripura state. I have just digitized the all the districts, all the available district of the state of Tripura. So let us see how now we can register an image into this frame where the shapefiles are created. So let us see, first of all, we go to this toolbox and then under raster tools, you will find image registration. Just double click on it and you will find this window. Now here you can import any image. It can be PNG image, it can be TIFF image, it can be JPEG image. Any image you can take. I am selecting here the TIFF image. So I am opening this. Now what I will do is I will just a little bit increase this point and just adjust the visual difference. Now what we'll do is we'll strike. I want to import this image or register this image into this framework. Okay, so what we'll do, we'll just click on any point of this image and then click on its corresponding point on this image. So this shapefile is actually digitized, has digitized the Shipai Jola, West Tripura district. So let us create the click another point in. So 1 1. Here also you can see the moment you are clicking here, so they are just showing the coordinates of point 1 and its corresponding point 2 in here. Suppose this 1 x1 y1, this is the coordinate of this point, and x2 y2 is the coordinate of this point. Why it is like this? 430.9385, because these are the coordinates of the computer, not of the latitude longitude. So don't get confused with this latitude longitude. Basically, this coordinate is showing the coordinates of the computer screen. Now let us do the same thing for this one and corresponding point on this one, then 3, then 3, and then 4, so just yes here. As many points you use, the more accurate will be the image registration. Here. So, I have created in total 8 points, and now I will click on the apply button of this one. Okay. And you see this entire image is transformed into this coordinate system, correct? And it is now stored in your computer system also. It is stored in the same location from where you will import this image. So let us now close this, and now what you will do is you will just go to the raster, add raster layer, because image is a raster. So now you will add the raster file, you see this is the image that you have used already georeferenced. Okay, now just click on open. You see exactly on the shape files it is being stored. Let us place this, move this image into the, sorry, let us move this image behind the shapefile so you can now see that. Now you see that this thing is exactly the boundary of the shapefiles, right? So now if I use this categorization, as you know, if you had watched my previous presentation, you can use categories. So now let us see with the help of, let us categorize these shape files with the help based on the average annual rainfall. So this is the color scheme, correct? And there will be 5 categories, and then you click on generate. So these are the 5 categories, randomly they will create, and now then you create, just apply, correct? Now click OK. You see now, you see just by seeing this image you cannot identify which shapefile or which polygon shapefile is representing which district. So for that, you just tick off the shapefile which carries the rainfall data, and you will find which district it has digitized. Yes, you can also use the labels, uh, which is you can turn on by going into the label property, pressing, and then you will just click apply. Yes, you can do that also, but still in the background, if this image is there, then it is very easy to identify which shapefile is representing which district. And not only this, now you will see that when I calculate the area of each of this polygon, how I can calculate the exact area instead of the area based on the computer coordinate system. So let us use this measure area tool. Let us use this measure area tool. Click on it, and then just digitize with the help of the boundary. Correct. So here what it shows is, I will do it again. This is around 0.08 hectare, right? And just, although this is not very accurate, it is coming around 0.9 hectares. Correct. So now the scale, your scale factor is 1:5,000, and you can see that let us say is now you can just undo point, or you can click on and go to properties, go to measuring. Here metric system is being used. Again, it is also metric, but you can use the hectares maybe also. So precision 1 means after point they will show only one value, one decimal or one digit. So if you can apply it, then you will find that it is showing 2 decimal, right? So this is coming up to 0.84 hectares. Okay, so this is 0.84 hectares. So now actually it is not 0.84 hectares, but your scale factor is 5,000, 1:5,000. So now we just multiply 5,000, say 5,000, and then you write point. So this is the area of this district with respect to hectare. 4250 hectares is the area of this district. Okay. So, but in this way, you can easily calculate the area of each of this district. You can use the measure area tool, or you can just go to this your table editor. Here already the area is showing. So I can again calculate, recalculate fields. So calculate. Sorry, then go to this has also been described in my previous tutorial. You can go to update measurements. Already there is existing field for area. Here square kilometer is selected. So you can select square kilometer or hectare, anything. It is your wish. Let us go with square kilometer because this is the standard, and then click on OK. So you see for this one, West Tripura, we have said for West Tripura, you see, so the area is as they have said in kilometers, square kilometers. Sorry. So this is the area. So this has been set to West Tripura. So this area was 0.085 hectare or 0.009 square kilometer. So now we have to convert this into this. You have to multiply this with the scale 1:5,000. So if you multiply it, it will give you the exact value. It was 0.85 hectare. Now it is showing that in square kilometer is 0.009. Yeah, so 45 square kilometer. So as you can see, the process. You first you have to register the image with the help of this one, image registration. Under the toolbox, image registration. You click on the image registration, this window will come. Now, whatever image you want to import in this coordinator, into this framework of your GIS software, you have to select it, and then you click on open. It will come here. Now, first adjust the points, adjust the zoom of this and this image. This is the map, this is the image. So let us zoom it more. Okay. And with the help of pen, you can just more or less. Right? When it is nearly of same size, what you will do is you start to register. First, click on one of the points in the map because you want to import this image into this. So just click on here and then you click on the corresponding point, singular point. This is the district, you can see. This is West Tripura. This is West Tripura. Click on here. Then for Kowai. Then for Talai. Then for Punabuti. Then for your North Tripura. Then for Supai. Just target the central point. Then for North. Then for South Tripura. So you can use 8 points. More the number of points, more accurate will be the image registration. After you have created so many points, you just click on apply and it will be transformed. Okay, so there will be some error. You can see there is some little bit of error is there, but anyway, this is what it is, and the error will also be shown uh, in that image registration window. Okay, so you can note down that error also. Now what you do is you just already I have created lots of georeferenced image or image registered image, but now I will again import one just to show you. Here the data is already stored in this image, and exactly it will come onto the upon the shape, right? Just move it back, but it is a little bit error is there in the image registration process, not as accurate as earlier. So here now then you can calculate the perimeter, calculate the area with either with these measuring tools, measure distance, measure area, or you can just use this field update measurements, correct? And whatever area or whatever perimeter is that they are giving, you can also change the units, kilometers, meters, all these things. But these calculations of area and perimeter is based on the coordinates of the computer. When you impose or you register an image onto the framework, onto your GIS framework, as I have done, I have registered that image into this GIS framework, it gives a ratio, a reference frame for the GIS software to equate with each other. That means whatever dimension is there in the real image of the districts, it gets transposed or transformed into the dimension of the created shape files of the GIS software. So then what you will do after you calculate this area and perimeter, check for the scale factor. It is 1 is to 5000. So you multiply the value, this value, with the scale factor to find the actual value of area, like or perimeter or any other dimension. Now, as for example, this area in square kilometers, so 0.009, you multiply 0.009 with 5000, it comes around 45 square kilometers. So 45 square kilometers is the accurate area of the district west. Correct. So this is the way you have to use to find the actual value of area, perimeter or length, etc. Okay. So here if we go for the length, if I go for length, this is 0.005, etc. So I just update it, and so we use the existing field. We will use the kilometer as you know. It has updated. So the scale factor is 1 is to 5000, 0.075. Again, bring out your calculator, 0.075 multiplied by 5000, whatever it is. I think it's in kilometers. So I think the length, 375 kilometers is the length. Okay, so this, yeah, this is the shape file. So we can show it. Let us turn off this shape file. Yeah, this one. So this way you can estimate, but uh, these are all estimate. This length and area, whatever calculation they are showing in the GIS software, these are all approximations. So just verify with the real value of the area. Suppose you already know what is the real area of West Tripura, then and you have found out the area from this process also. Then you equate like for example GIS is saying that the area of West Tripura is 45 square kilometer. Internet or your information is saying it is 100. So 1 unit is equal to 45 unit of GIS is equals to the 100 unit of this real units. So what is the 1 unit of GIS equals to 100 by 45 real units. So when you know this ratio, you can easily find out the real length of the or real length and area of each of the geographical features with the help of this software. I want to repeat it again. So this is 370. So if I open my pen, I just want to write something. So I am opening the pen. Suppose, for example, you find that area of West Tripura is 45 square kilometer. After you have multiplied the area with the scale factor. So this is now you have find after searching the internet you will see that the area of West Tripura is actually 100 square kilometer actually. So 45 is equals to 100, then 1 is equals to 100 divided by 45. So it is coming around, again I have to go for calculator, so it is coming around 2.22. So now if you find some area on the same map is 120 square kilometer in GIS, then just multiply 120 into 120 multiplied by 2.22. The result will be the actual area of that district. So once you find this real scale factor with respect to the actual value of the area and the calculated value of the area of a shapefile, then you can convert the area of other shapefiles also into the actual value. So this is what you have to do when you want to find the actual area and perimeter or length of some geographical features with the help of your GIS software. This map